First of all, let's do a quick recap of the oxidation of the different classes of alcohols before we test for their organic products. This alcohol is a primary alcohol because the carbon to which the OH is attached is only attached to one of the carbon, which I've put the symbol here for the rest of the molecule. When a primary alcohol is oxidized, we lose 2 atoms of hydrogen, which then combine with the oxidizing agent and we form water. Therefore, the organic product is exactly the same skeleton, it's not changed at all. And where we had a single bond oxygen here, we now have a double bond oxygen, and that class of compounds is called the aldehydes. And what we're going to do is to see how we can identify aldehydes using a chemical test. Secondary alcohols have 2 carbons joined to the carbon that's attached to the oxygen and hydrogen. If in this case we lose 2 atoms of hydrogen that combine with the oxidizing agent, again we form water. And to draw the structure of the oxidation product, here it's exactly the same skeleton. We've lost the 2 hydrogen atoms, so the carbon double bonds up. The product of oxidation this time is in a slightly different class, even though it contains the carbonyl group. This is now a ketone, where the carbon double bond oxygen is surrounded by 2 other carbon atoms. So this is a ketone. And it is possible to distinguish between aldehydes and ketones because aldehydes can undergo further oxidation, but ketones cannot. And let's remind ourselves about tertiary alcohols, where the carbon to which the OH is attached is not joined to any other hydrogens. These are unable to undergo oxidation under normal laboratory conditions because, as you can see, there are no hydrogens directly attached. So the difference between aldehydes and ketones is that aldehydes can undergo further oxidation and ketones can't. So let's now look at a chemical test for aldehydes. The chemical tests all involve redox reactions. At AS, you just need to know that the silver ions, which are dissolved in ammonia, will react with the aldehyde and the silver ions get reduced to silver metal, and therefore they need to gain an electron. The aldehyde, in this case let's look at an ethanol, is going to be oxidized even further to a carboxylic acid. In this case, it's going to be ethanoic acid. Let's quickly balance this redox reaction. So we know that if we have an extra oxygen on one side of an equation, we need to add in water on the other side. We now have an imbalance of hydrogen atoms because on the left-hand side here, we can see that we've got 6 hydrogens and on the right-hand side, 4 hydrogen atoms. So to balance for our hydrogen atoms, we now need to add hydrogen ions. We now have an imbalance of charge and therefore we need to add 2 electrons to this side, to the more positive side, to balance out the charge. So we need to balance this equation because the oxidizing agent, this in this case is the silver, is going to take 2 electrons and the reducing agent, that is our aldehyde, is behaving as a reducing agent, will lose 2 electrons and these will be passed on to silver. So we can get silver metal produced. Those of you who are doing A-level know that when the silver dissolves in ammonia, it forms a complex ion, diamino silver. Don't worry too much about this if you're A-level, if you're AS level. And this reagent, our diamino silver, is called Tollens reagent. For those of you who are doing A-level, this is a linear, complex, and in a colourless solution. So this is your oxidizing agent. Let's see how we make Tollens reagent. A beaker
silver nitrate solution, ammonia, propanol, a pipette and a clean test tube. We start by adding about 2 centimetre cubed of silver nitrate solution to our test tube. We're now going to add the ammonia solution. It's important to add this drop by drop. As you add it drop by drop, give it a shake. You should see initially a precipitate of silver oxide forming. Right. There we go, and then it disappears. So, boiling water ready in our beaker. We now take our propanol. You want to add about 10 drops and you need to add these quickly. Okay? Quickly, bung on, give it a good shake, place in the water.
You can now see that the silver metal is being precipitated on the side of the test tube. This is called the silver mirror test, and it's only positive for aldehydes. It will not work for ketones. Fehlings solution is another way we can test for the presence